All right. So now we're doing TryHackMe's pre-security, network fundamentals, extending your network, task 5, LAN networking devices. All right. So what is a router? A router's job is to connect networks and pass data between them. Gotcha. It does this by using routing, hence the name router. Oh, okay. Routing is the label given to the process of data traveling across networks. Routing also involves creating a path between networks so that this data can be successfully delivered. Okay. So it makes a path and it travels. All right. So routers operate at layer 3 of the OSI model. Layer 3 being the network layer. All right. They often feature an interactive interface, such as a website or a console, which I guess we'll see later, hopefully, that allows an administrator to configure various rules such as port forwarding or firewalling. Routing is useful when when devices are connected by many paths, such as in the example diagram below, where the most optimal path is taken. All right. So this router, now that we've done this a few times, is a computer 1 and computer 2. This router belongs to computer 1. This is a router out there on the internet, and this is another router out there on the internet. And then we've got this router, which is connected to computer 2, right? And so it's going to choose either to go this one or this one, depending on certain factors, all right? So routers are dedicated devices and do not perform the same functions as switches, okay? We can see that computer A's network is connected to the network of computer B by 2 routers in the middle, 1, 2, right? The question is, what path will be taken? Different protocols will decide what path should be taken, but factors include what path is the shortest, what path is the most reliable, and what path has the faster medium, for example, copper or fiber. I mean, we've gone over this quite a few times so far, right? And now what's a switch? A switch is a dedicated networking device responsible for providing a means of connecting to multiple devices, all right? Switches means to connecting multiple devices. So I guess a router connects to one device and switches connect to multiple devices, right? Switches can facilitate many devices from 3 to 60. That's not right. Obviously this is a typo because we've seen before it's 4 to 64. And also in computing, these numbers do not show up too often, all right? So we know there's a typo, 4 to 64, all right? Using Ethernet cables. So switches can operate at both layer 2 and layer 3 of the OSI model. So both the data link layer and the network layer, right? However, these are exclusive in the sense that layer 2 switches cannot operate at layer 3. Okay. Take, for example, a layer 2 switch in the diagram below. So this one right here. These switches will forward frames. Remember that the original IP packets are encapsulated within the frames onto the connected devices using their MAC addresses. All right. So yeah. So this thing is going to throw frames this way instead of IP packets. Okay. So these switches are solely responsible for sending frames to the correct device. All right. And so we need to remember that when we start doing Red Hat stuff, when we start doing hacking and all that. Now we're going to move on to layer 3 switches. So these switches are more sophisticated than layer 2 as they can perform some of the responsibilities of a router. Okay. Namely, these switches will send frames to devices as layer 2 does and route packets to other devices using the IP protocol. Okay. We gotta study up on this stuff. I hope they give this that because this is, I mean, it's not that it's confusing. It's just that it's very vague. Anyway, let's keep going. So let's take a look at the diagram below of a layer 3 switch in action. This one right here. We can see that there are 2 IP addresses. We got 1.1 and 2.1, right? So we've got 1.1 over here, which you can't see, but on your computer, you should be able to. And 2.1 over here, right? A technology called VLAN or virtual local area network allows specific devices within a network to be virtually split up, okay? This split means they can all benefit from things such as an internet connection, but are treated separately. Okay. This network separation provides security because it means that rules in place determine how specific devices communicate with each other. This segregation is illustrated in the diagram below, right? So yeah, basically this says, if you can't read it, which I can barely, it says sales department, and this one, it says accounting department, and VLAN 1, VLAN 2. So it separates the sales department from the accounting department, and these can talk to each other, but these cannot talk to these, all right? I don't know how that works, but hopefully we'll see it later, right? So in the context of the diagram above, the sales department and accounting department will be able to access the internet, but not be able to communicate with each other, although they are connected to the same switch. Now, I don't know, like, do they have like messengers for this one and a messenger for this one? I don't know. Well, hopefully we'll get into that later. But anyway, let's answer these questions. So what's the verb for the action that a router does? I bet you it's routing. Let's see if I'm right. There we go. So what are the two different layers of switches? Separate these by a comma, i.e. layer X or layer Y. So we're going to do layer 2 and, layer 2 and layer 3, not 4, 3. And submit it. Looks like it's the winner. All right. So now we're on to task 6, practical network simulator. And we'll see you next time.